Hi everybody, it's Mr. Nicole again. We're going to do Chapter 3 notes on tissues. First question is a thought question. So I'd like you to pause the video for a moment and ask yourself, what is a tissue? And then think of any of the four major kinds of tissues that you already know about. Pause the video here and put some answers down. Okay, so hopefully you answer thought question number 1. And the four different kinds of tissues start with the epithelial tissue. If you remember in class, we had talked about a tissue is a collection of cells that are all working together towards a common function or functions. So here we have epithelial tissue as the first one, and there's a lot to say about it. This epithelial tissue, most likely no one ever gets this one on the thought question. Not a common one that people talk about, but it pretty much is the tissue that you see when you look at somebody, as it covers all body surfaces, both inside and out. Now when I say inside and out, I obviously mean the skin and the outside of your body, but if you think about it, you got a bunch of holes in your body, and those openings are in contact with the outside world. So just think of your mouth, for instance. The tissue that goes all the way down to your mouth, all the way down to your throat, and into your lungs, into your stomach, into your intestines, and out the other end, is open to the environment. So epithelial tissue lines all of those openings. So you have a lot of epithelial tissue. It's got a lot of different functions. It protects, like the skin protects in many different ways. Absorbs materials, it filters materials. It can also secrete materials. Epithelial tissue, most of it doesn't have its own blood supply, but cell can reproduce very rapidly if near a blood supply. So a blood supply really means you're a capillary, and we know the concept of diffusion. So oxygen, carbon dioxide are among other materials that they're fusing out from capillaries. Glucose is one of those materials. So if the cells are near a blood supply, they can access those materials. And if they are near that blood supply, they can reproduce very, very quickly. Your skin is constantly reproducing your skin. That makes sense? Your skin is constantly being remade. Cells are constantly being reproduced and pushed to the surface of the skin, and your skin is constantly flaking off. And with most of this tissue, they are tightly packed together, as it makes sense not to leave any space for bacteria and viruses to try to get through. Still, some are able to get through. The outer skin is very tightly packed, so it's extremely difficult, if not impossible, in most areas of the body for organisms to get in there. Bacteria don't do a very good job of that. Viruses don't do a very good job. Fungus is pretty much the only one that can really get into the skin, but even then, it only gets into the surface of the skin. So think of things like ringworm, athlete's foot. Those types of fungal infections don't go too deep down. There are exceptions, but a lot of the really bad infections come from the inside of the body and work their way out. But like I said, there are some other exceptions to that bacterial. But for the most part, the skin does a very good job of keeping it out. When you get further into the body, though, the body wants to take in materials like oxygen and carbon dioxide into the lungs. So there's more potential there for bacteria and viruses to get into the body through those areas. Materials have to be exchanged. Alright, so we've got thought question number 2. So pause the video here. Based on the definition of epithelial tissue, what are some other places in and on the body that you would find epithelial tissue? So I said a few obvious ones, so try to think of some other ones. Alright, hopefully put a little question down there. We're going to talk about more where we find them and definitely the shapes of them. So epithelial cells have many different shapes that they come in. A lot of different types of cells. And their names, or should I say their names of their shapes, correspond with their function. So a simple in front of the word, whatever type of tissue, simple epithelial tissue for example, it's going to mean single layer. So if it's only a single layer, these types of tissues are very good at absorption and secretion, allowing materials go in and out. Stratified just means many layers. Most likely it's going to be a barrier of some sort, like your skin. Squamous means flat. So your skin is stratified squamous epithelial tissue, meaning that's many layers. Of course, it's not that many, but most of the cell thickness on the outer epidermis is 30 to 50 cells, and it's even thicker on the hands and feet. You also have cuboidal and columnar, so these are square and rectangle shapes. So we got many examples here. We got simple squamous, diffusion filtration. These would be like in the alveoli, the lungs, or in the capillaries. Simple cuboidal, again, so it's single layer. These are for secretion and absorption. So these are found in the kidneys and also in the ovaries, among other places. So simple columnar. So these are providing a little bit more of a barrier because of the shape of the cell. Prevents some materials, bacteria and viruses, from squeezing through because they are not flat. So, but it still allows materials to go through those cells. This is found in digestive tract and the uterus. So it's for secretion and absorption. The uterus probably should be really specified to say more the placenta, because materials need to go into the baby who is in the uterus. Stratified squamous, many layers of flat. So this is the skin, mouth, and tissues going into your pharynx, which is the back of your throat, down your esophagus, and your trachea. So they're there to provide some barriers, support. So here's a picture of your skin. You can see here you got a layer of the epidermis. This is a really thin layer, and you can see some of the cells hanging out in there. So here you can't see the flattened cells too much. I mean, when you take different parts of the skin near your fingers and your hands are going to have a lot more flattened cells. I mean, just think of a skin callus. So those are a bunch of dead cells all packed tightly together. You got other parts of your body that don't really deal with friction too much. So this might be on a part of the body. It doesn't feel a lot of friction. So it'll be a lot of your skin. So it's not very thick here. You can see this thicker layer. This would be somebody who has some dark coloration in their skin. So you can see some of the pigmentation of the melanin. We'll get to that when we talk about the integumentary system. Another one, we have pseudostratified columnar. These are lining the passages leading to the lungs, so your bronchial tubes, and then the bronchioles, and then the alveoli in the lungs. These have little hairs sticking out of them. Kind of see them over here. So they're semi-stratified. So sometimes you have a single layer. Sometimes they look like there are two layers, but they're really just long columns, rectangles here, and you kind of see that. But these little hairs will flap in unison, and what they do is they take dust and other crap that you breathe in your respiratory system, and they actually move them like boat oars to the surface. So on here there might be some dust particles, there might be some bacteria, viruses. So even when you're not sick, you do cough up a bunch of stuff, and it's just stuff that you're breathing in, and it accumulates, and these little hairs bring it out. And then you have something called transitional epithelium. Basically, this is very stretchable. So you found this in the urinary bladder, and obviously the placenta can be stretched quite a bit too when there's a child in there. But this blocks diffusion, so no leaking out. So you don't want urine leaking out of the bladder. So a lot of different kinds of epithelial tissue in different places in the body. The second type, you might have gotten this one on the thought question. This is connective tissue. So it's the most abundant in the body. Epithelial tissue is going to be close second. Muscular tissue is right up there also. Nervous tissue is the one that has the least amount. There's a lot to say about connective tissue also. So this not only just connects different tissues, but oftentimes has a protective function. And a real big thing that does is it gives structure. Some of this tissue is involved with the immune system and fighting infection. You have some fat tissue that's technically connective tissue, and you have tissue that produces blood cells. So connective tissue, in most cases, is going to have a matrix with numerous types of cells, fibers, and non-living substances. So a lot of connective tissue, a portion of it, depending which one you're talking about, is actually not made of cells. So what that's really saying, fiber is made out of protein. Non-living substances. I mean, think of bone. Bone has a lot of calcium and phosphate in it, which is basically rocks. Bone is very much a living tissue because it has cells and neurons and blood vessels in it. But it's not completely 100% living. It has so-called dead components to it. if I click on this link here, so we have definition of matrix: an environment or material in which something develops, a surrounding medium or structure. So basically what happens in the vast majority of connective tissue, there's a non-living substance that forms the backbone or the structure that the living cells attach to and build off of from there. So for like a building, this might be like the steel girders that make up the building, and then many other materials are added onto that, like the wood and the walls that make up a classroom and the floorboards, etc., etc. So the matrix would be the metal, so to speak. So for like bone, it would be the calcium phosphate rocks, and there's something called collagen fibers that make up the bone in their bodies. And cells will attach to these different matrices, and they'll build portions of the bone, and the living tissue will grow from there. So pretty interesting stuff. Let's go back to here. All right. So thought question. So thought question number 3. Based on definition of connective tissue, what are some places in and on the body you might find connective tissue? So write down like 2, 3, 4 different places you might find it, based on what you've heard for the definition here. So stop the video for a moment. Okay. So hopefully you found some different places. I mean, connective tissue, you might be thinking like tendons, ligaments, we obviously said bone. Alright, fat tissue, blood vessels, blood tissue. Hopefully put something down like that. So we'll explain a little bit more. Connective tissue usually has an excellent blood supply, and the cells are able to reproduce extremely rapidly. The exceptions are tendons and ligaments, and also cartilage. Tendons and ligaments have a very poor blood supply. They sometimes are near blood, so they can get some materials, but for the most part, when the tendon ligaments become damaged, it takes a long time for them to heal because they have a lot of trouble getting the raw material from the blood. And cartilage has no blood supply at all, so it relies on diffusion from surrounding blood vessels. And a lot of cartilage in our body is sitting in the middle of a joint where there are no blood vessels, there is no blood. There's synovial fluid in there that lubricates the joint. But it takes a long time for materials to move from the blood into the synovial fluid and into the cartilage. So it has to gather raw materials to rebuild in the damaged cartilage. And you may or may not know, we'll talk about this more when we do the skeletal system, but tendons and ligaments have there's a limit to how much they can repair themselves when they're damaged. And same with cartilage. So if you tear a tendon or ligament or cartilage, all the way, or a certain percentage, 80, 90, 70%, the body's not able to fully repair it. And that can have some pretty bad repercussions. Basically means surgery and pain. So here's an example. We got ligament. This is the ACL, very commonly injured in sports, skiing and football. I myself, I'm on my 3rd ACL. I damaged it when I was 16 years old, and I had it repaired about 4 years ago. So I'm on my 3rd one. The first one was my own. The second one was a synthetic one that they were trying out, but they found it didn't last very long. It lasted quite a while for me. It lasted 20-something years for me. So now I have a dead guy's ligament in my knee. Interesting. Well, when this gets damaged, this is the one that always gets damaged because when the knee bends in the wrong direction, usually it's from getting hit from the outside, somebody falling on it. So your knee falls to the inside of your body. And this is the one that will tear. And if you have a serious tear, the body can't repair it. So you have to get another source, which is usually from cadavers. Sometimes they can take it from another part of your body. Sometimes they can take a tendon and put it in there. And like I said, they used to use some synthetic ones. But the best raw material so far is material that you can get from harvested from the human body itself. So here's a picture of the collagen fibers, the matrix portion of a tendon and ligament. So it's extremely dense. You get these cells called fibroblasts that sit in the middle, and they're the ones that make the collagen fibers, and they're the ones that weave it together into the extremely strong tissue. Another picture of it here. So these guys obviously get enough glucose and oxygen to survive, but it's hard for them to extract the raw materials. It takes a while for them to get the amount of raw material to build new connective tissue. So in this case, you can see BV means blood vessel. So these cells would reproduce this type of tissue very, very quickly on this particular area. So this would be probably closer toward where the ligament or tendon were attached to the bone or the muscle. But if you get to an area that's farther away, there's no blood vessels in the area. So going back to that thought question, number 3 earlier, where do you find connective tissue? Well, we have bone. So like I said, it's got a matrix of cells, collagen fibers, and calcium phosphate rock. Cartilage, tendons, ligaments, which are all part of, like I said, in your skeletal system. Areolar tissue is a fluid tissue. This is the loose packing tissue, which sounds gross, of your organs. So this is pretty much the tissue that you would find in your body cavities. All right. We know that fluid is not compressible, so if it's in a place that needs to be compressed, the fluid would simply move to a different area. So, like I said, your body is squishy. So there's some space in there where fluids can move around. And then we have adipose tissue, which is basically fat tissue. And then we have the blood. It's a picture of fat tissue. So these fat cells, if the person is eating more calories than their body is using, the body will store a portion of that in fat cells, and it'll distribute it to different places depending on if you're a male or female. That's because of hormone reasons. And the fat will sit there and it'll wait to be used. It'll wait for a famine to come, which doesn't come in our modern times in our country for the vast majority of people. So people stay that way unless they diet and exercise a little bit more and eat less. That's for another topic, for another day. Here's a picture of the areolar tissue. So it's the loose packing material that's in the body's body cavity. And this is bone. So a lot of people think these are the cells, but it's actually the black dots here. Are the bone cells. This is where a blood vessel would be. This is called Haversian canals. And these are called canaliculi. These are little canals that come off of there. So materials will diffuse out of that blood vessel and go to these black dots where the bone cells are. And these cells are called osteocytes, and they make the bone material. They make the collagen and calcium phosphate mineral, and they weave it together into what we know as bone. Here's some cartilage, hyaline cartilage. So you find this in the ends of joints, your nose, respiratory passages. You can see these cells. These are called chondrocytes. So these make the cartilage. And this is also made out of collagen fibers also, but it's got a more of a watery mixture in it, so it's a little bit more flexible. And this picture of blood. You have red blood cells and a white blood cell, which is weirdly enough a connective tissue. So in some ways, I guess it does connect the body. The last two tissues, not too much to say about them, the muscle tissue and nervous tissue. We'll obviously spend a lot more time in these. Most people would guess, when they're thinking of tissues of the body, they think of muscle tissue and nervous tissue. So you got 3 different kinds. Skeletal muscle is attached to the skeleton, cardiac's in the heart. Smooth muscle is in any tube inside the body that can restrict the movement of materials. So it can restrict or dilate. The digestive system, blood vessels are smooth muscle. Cardiac muscle, like I said, only in the heart, and strangely enough, it does not reproduce. Or I should say, does not reproduce and repair itself. When there is damage to its cardiac muscle, it doesn't just make new ones, it makes scar tissue, unfortunately. Someone has a heart attack, oftentimes if they survive, they have scar tissue on their muscle. Scar tissue does not pump blood very well. That's for another day, we'll talk about that. Here's some pictures. So muscle it's fibrous in nature. And this is a little bit different than the tendons and ligaments we saw earlier. Smooth muscle is named because it doesn't have these striation lines like you can see in there. We'll talk more about those later. Nervous tissue, I'm not going to say too much. Nervous tissue is made up of neurons, and many hundreds, sometimes hundreds of thousands of neurons when they get put together in a bundle along with blood vessels and a connective tissue sheath that ties them together. We call that a nerve. But the individual cells of real nervous tissue components are called neurons. So they're specialized cells for sending and receiving electrochemical messages. You got some pictures, basic pictures of what they look like here. And here's a microscope slide. This one is the neuron itself, and these are the branches of the axon terminal and dendrites that reach out to other neurons. They communicate by sending electrical messages back and forth. So this is a picture of some of the spinal cord. Alright, that's it.